All right, so let's just do a general review on logs. So the first thing that you need to be able to do is to go from a log with a particular base to writing it in exponent form.
Okay.
So if we're looking at a log, this number is the base. That number is the answer. And then that number would be the exponent. So if I want to write this in exponent form, I take this number, I put it underneath that number, and then I keep the 9 exactly where it is. So you get 9 is equal to 3 to the x.
2.
And so x would be equal to 2. So that's kind of the first rule on how you go from a log to an exponent form.
Okay.
If I am looking at two different bases, and I have no idea whether this question is going to work out or not because I've just made it up.
Okay.
But the first thing that you have to do when you're dealing with exponents is to make these two numbers exactly the same, right? So I'm going to change this 9 to a 3. 3 to what power is 9?
3 squared.
So that's to the second power. So that means that the exponent that was there has to be written like that.
Okay, so it's 2 times 3x plus 2.
And now I can say, since these two bases are the same, I can say that the exponents are equal to one another. So now I get an algebraic equation. And I don't like the way this is going to work out because I'm going to end up getting 0. But anyway, we'll just do it anyway. So you get 4 is equal to 6x
You can always do it like
plus 4.
You can always pretend it's just negative 2.
Yeah, I could do that. I could do that. I can also change this to like 14. Why don't I do that? I'm going to make that 14.
Okay.
Just so it actually makes sense.
Has the pollen hit in your voice?
Yeah, my voice is being robbed, and I'm always dried out. It sucks. Okay, so we move the 4 over to both sides, and we get 10 is equal to 6x. And so x is equal to 10 divided by 6, which is equal to 5 over 3.
Yeah.
And so,
like that.
Yeah, so that's what the exponent would be.
I think it's like 5.2.
Yeah, we don't need a decimal. We just leave it in fraction form because we're dealing with exponents anyway.
Oh.
Because when you're dealing with an exponent, 3 to the 5/3 power actually means something. Do you know how to rewrite that?
Not off the top of my head.
Well, this would be 3 to the 5th, and then I'm going to third root it. Right?
Yeah.
So that actually means something, so you leave it in fraction form.
So would you just like, would you write 3 out 5 times and then?
Well, when we're trying to rationalize this, and this is like something that you learned earlier this year too.
Okay.
How many times does 3 go into 5?
Does 3 go into 5?
How many times does it go in evenly?
Once.
Once. So you end up with 1 with a remainder of 2, right? If we do it in long division, and you have 3 and you have 5 there, it goes in 1 time. 1 times 3 is 3. You subtract those two from one another, you get 2. So you get a remainder of 2.
Okay.
So when I'm going to write this out, I have this as my power that's on the outside of the radical.
Mhm.
So you get 3 there. And then this number is the number that's in the inside of the radical, so you get 3 squared there. That's actually how you rationalize that.
Could you put 9 in there as
You
well?
could put 9 in there. You could write this as 3 cube roots of 9. You could do it that way.
I didn't know you could do
I taught you that
that. You
already.
probably did, but my memory right now, the whole like change in medications is like affecting my memory. Like I'll be like midway through sentence and I'll go, wait,
What was that?
what was I talking about? I'm aging by like every hour.
Okay, so I'm going to stop taping.